Okay, so I have a request to help with the vernier caliper problem in experiment 1. So I'm just going to make up some data here. So let's say, for example, that the volume I calculated with the cylinder equation is in millimeters cubed, because our measurement was in millimeters. Let's say, for example, I had a volume of 4 millimeters cubed. Okay. To convert this into centimeters cubed, so we talked about this quite a while ago, but so centimeters cubed into millimeters was like on the first day of class. So cubic units are interesting. So we know that the relationship between a centimeter and a millimeter is this, or you can derive it from what you know about the base units, i.e. that there's 100 centimeters in a meter, and there's also 1,000 millimeters in a meter. So these are kind of, this is the proportionality. Rather than having extra zeros, I'm going to simplify so that 1 centimeter is 10 millimeters. Now, to get this into cubic units, I have to cube this entire relationship. I can't just cube the units, okay? So that means 1 cubed is 1, and the unit has become centimeters cubed on the top. 10 cubed is, so 10 cubed would be 1,000 millimeters cubed. So there's 1,000 cubic millimeters in 1 cubic centimeter, okay? All right, so then now that we know that, I can go back to the volume that we had and do dimensional analysis as usual. The reason I chose to go to centimeters is because the 1,234 is actually a very small volume for this. Most people probably have around 3,000 or 4,000, so it's a big number, and so it doesn't really make sense to use millimeters for it. Okay, so this is going to end up being 1.234 centimeters cubed. Okay. So, this would be from my vernier calipers. There should be lots and lots of significant figures. In fact, there should even be one more than I put here. So, my original measurement should have had a tenths place there. Maybe even a hundredths. Anyway. So anyway, the volume of water displacement could be something like, I don't know, I'm just going to make one up, 2.1. And I got that from subtracting before the slug was put in from after it was. And so this will be water displacement. And our measurement from the vernier calipers will be something like this. Cubic centimeters is milliliters, so I can convert that like that. And so to do a percent difference, the formula is reading 1 minus reading 2. So that just means the biggest one minus the littlest one. So in my case, it would be 2.1 minus 1.234 milliliters. And then divided by the average reading. So in this case, it would be 2.1. That looks bad. Plus 1.234 divided by 2. And then all of this gets multiplied by 100 because it's supposed to be a percentage. And so on the top here I get 0.866 from my calculator, but the sig figs for that is different because we're subtracting, so it's place value. So my lowest place value is tenths there, so that means this is my last significant digit there. And then the average is 1.667, again because of the addition right here. There we go. Because of the addition right here, that has to be the tenths place. And then this whole thing is still multiplied by 100%. Okay. So what we get out of this is the relationship between sort of these two values. How different are they? The bigger the percentage, the bigger the difference. In this case, I got 51.9496 from the calculator. I only have a tenths place, which is just basically one significant figure, so I'm going to just sort of arbitrarily say 52%. Okay. So that's how I do it.